So for grade 9, I'd like to know that solving linear inequalities follow the same principles as solving linear equations. But there's only one difference, which is when you multiply or divide by a negative number, you need to reverse the inequality sign. So for grade 9, we are going to look at 3 scenarios involving solving linear inequalities. And our first scenario involves addition and subtraction. Addition and subtraction. Subtraction. Addition and subtraction. So let's look at an example, a very simple example. If you have x minus 7 is greater than 10. X minus 7 is greater than 10. For normal linear equation, we'll have something like x minus 7 equals 10. And we'll have x equals, we take negative 7 to the other side, it's become positive. So we'll add 10 plus 7. And we'll have that x equals 17. So that's a scenario of addition. For linear inequalities, we'll do the same thing. That's the same principle. We'll have x, and then we'll take this negative 7 on the other side. We'll keep the sign, which is greater than, and we'll have 10 plus 7. So we'll have x is greater than 17. X is greater than 17. That's a scenario that involves addition. Let's look for another scenario that involves subtraction. Now we have x plus 3 is less than or equal to 5. For a normal linear equation, it will be x plus 3 equals 5. So when you have x plus 3 equals 5, we'll just have x here, and then we'll take 3 to the other side and it becomes subtraction. So it will be 5 minus 3. So x will be 5 minus 3 is 2. While using the same principle when solving linear inequalities. Let's use the same principle. This will be x. Now plus 3 will move to the other side, and we are going to maintain our inequality sign, which is less or equal to. So we are going to take our positive 3 on the other side, so we'll have 5 here, and when we take positive 3 on the other side, it becomes a negative. So our x will be less or equal to 2. X is less or equal to 2. So that's the first scenario that we have to know in grade 9. Let's look for another one. Let's look for another operation. For the second operations, now there are times that you love operations involving multiplication and division. And division. Now, this is where you have to be a little bit more careful, because as indicated here in red, the only one critical difference between solving linear inequalities and solving linear equations is that multiplying or dividing, can I use this one here? Multiplying or dividing by a negative number reverses the inequality sign. Now, when multiplying or dividing by a positive number, the signs remains the same. If the number is negative, we must flip that sign. We must flip the inequality sign. So let's look at a simple example. If you are asked to solve for x, and you have 3x is less than or equal to 24. For linear equations, it will be 3x equals 24, and we'll just divide both sides by 3 to isolate x. So we'll have x equals 8. That's a normal linear equation. But for inequality, we'll do the same thing and maintain the inequality sign. If and only if we are working with a positive number, and here we have a positive number, so let's isolate this x here. We have 3x, 24. Let's isolate this x by dividing by 3 both sides, and then x here is less or equal to 8. And we are not changing anything because it's positive. Yeah, we have divided by not changing anything because it's positive. Let's look for another scenario. Now, another example is now in this case we are going to have a negative. Let's have a negative. Any number, yeah, less than 30. This one, for normal linear equation, it will be negative 3x equals 30. And we'll just isolate x by dividing by negative 3. And this will have, our x would be, this is 1, this is 10. Our x will be negative 10. This is for linear equation. But for linear inequality, the sign will not remain the same when you are dividing by a negative. So in this case, if the number is negative, we must flip the inequality sign. Let's have this one here. Which color can I use here? It is just the same. This one. Let me use this one. So here we are going to isolate x by dividing by a negative 3 and by negative 3. But when you divide by negative 3, we must flip this sign here. So our answer is going to be, when you divide this by this, cancel, we're going to have x. But we must flip our inequality sign, and it's going to change to greater. So it's greater than, here is 1, now this is negative 10. So we have negative 10. Remember that we must flip the inequality sign when you are dividing or multiplying by a negative number. Now let's look for another example. Now this is the last example. if we have x over 5, or x equal 5 is less than 2, in a normal linear equation it will be x over 5 equals 2, and you just multiply both sides by 5 to isolate x. So we'll have x equals 2 times 5, and the answer will be x equals 10. Now, as you can see here, our 5 is positive. So if our 5 is positive, anything that you are going to do with a positive number is just the same as you could have done with a normal linear equation. So when multiplying or dividing by a positive number, the sign remains the same. So our sign will just remain the same, and we are going to have here multiply here by 5 and multiply here by 5. Then you cancel this and you cancel that, and then you have your x is less than 10. Remember, our sign has just remained the same because we are multiplying by a positive number. Now let's look at the last operation. We can have an operation that has both an equation, an equality equation that has both operations. So there are times that you can be asked to solve an equality with more than one operation, more than one operation. So when you have more than one operation, what do? We'll just use the same principles that we've been discussing, except we have to be careful. You have to be careful with multiplying or dividing by a negative number reverses the inequality sign. So let's look at a simple example. Very simple example. Suppose you have been asked to solve for x. Solve for x when you have 5x plus 4 is let's say less or greater than 19. Less or greater than 19. Now here we are just going to use our normal principles that we've been using in the normal linear equations. So we just have our 5x here, and then we'll take the positive 4 to the other side. This is our sign, and then you have 19, and when we take our positive 4 to the other side, it's become a negative. So we'll have 5x. This is just our sign. 19 minus 4 is 15. And then you need to isolate x by dividing both sides by 5. And then when you divide by 5, you'll get your x here. The isolated x is less or equal to 3. It's less or equal to 3. This is so simple. Let's look for another one that might be a little bit more challenging. Now for this one, we have we need to solve for y. Let's have here 6, and let's have y here. Then y minus 3. Then let's say that it's less or equal to 42. Less or equal to 42. Now to solve this one, we'll use the same principle. So let's open the bracket. 6 times y is 6y, and then you have a negative here, and then 6 times 3 is 18. And so this is our sign here, is less or equal to 42. Now the next thing we're supposed to do is to take this negative 18 on the other side to isolate y. We are trying to isolate y, so let's have our 6y here, let's have our inequality sign here, and then we have 42, and then plus 18, because it's also negative. When it's come on the other side, it's become a positive. Now 42 plus 18 is 60, so we have our 6y here, this is our sign. 42 plus 18 is 60. Now let's isolate y. Let's isolate y by dividing both sides by 6. Now you have your y. Let's maintain our sign because we are dividing by a positive number. Let's maintain our sign. And we have 10. You have 10. So that's the answer. Y is less or equal to 10. And let's look at the last one. The last example. Suppose we want to solve for t. Yeah, suppose we want to solve for t. We have here 5t plus 7 is greater than 9t minus 13. So let's try to solve for this t. Here we are going to collect like terms together. We are going to collect like terms together in a bid to isolate t. So you have your 5t, and now why do you have t again? You have 9t here, so let's take 90 to the other side, minus 9t, and then our inequality sign is here, and then we have our negative 13 here, and then we take this 7 to the other side, so negative 7. So we have collected like terms together. The next thing is now let's subtract 5t minus 90. 5t minus 90 is a negative, so we are going to have a negative 40 here. Negative 40, and then let's maintain our sign, and then negative 13 minus 7 is negative 20. Negative 20. Now to isolate t, we are going to divide both sides by negative 4. You divide by negative 4, you divide by negative 4. So here and here we will have t. Now for the sign, I want you to be careful with the sign, because we are dividing by a negative number. We are going to flip our sign. We are going to reverse it. It was greater than, but now because we are dividing by a negative number, we are going to reverse this to less than. After reversing it, now we can simplify this one. Negative 4 is 1. Then here we have positive 5. When you divide two negative numbers, you get a positive number. So here we have our 5. T is less than 5. So I hope that is so easy. So that's how we do it. Now let's test ourselves with this multiple choice practice. There's two simple questions. Now the first one is y. We are solving for y in the inequality. Y plus 12 is less or equal to 5. So here we are going to isolate y by checking to off the other side. So y, we are going to maintain our inequality, and then we take it to the other side. We have 5 minus 12. Because it's a positive and it's moved to the next side, to the other side, becomes a negative. So y is less or equal to 5 minus 12 is negative 7. Negative 7. So our answer is y is less or equal to negative 7, and that's just B. Yeah. Now for the second one. Which of the following is the solution to the inequality negative 4x is greater than 20? Now to get x, we need to isolate it by dividing both sides by negative 4. So we divide both sides by negative 4, and we will have here 1, we will have our x. And since you are dividing by a negative, we are going to flip our inequality sign. We are going to change this inequality sign. So let's flip it. It is greater than, so it's going to be less than. And then here, when you divide, you get negative 5. Negative 5. So our answer is x is less than negative 5, and that's just D. Yeah, just simple vectors.